Welcome to Spring LIB.
Okay, so what exactly is implicit differentiation? Well, this means I'm taking the derivative of an equation that doesn't have just y equals something of x. X and y are both on same sides of the equation. And I'm still going to take the derivative dy over dx of both sides. Okay, so I'm going to take this with both sides. And the way I'm going to do this is with respect to x. So, well, I'm actually just going to take d over dx of both sides. The derivative with respect to x of both sides. Okay, so how do I do this on the left side? Well, this is the product rule. Product rule, derivative of the first, derivative of x is just 1 times the second, plus the first term times the derivative of y with respect to x, which is just dy over dx. So I'm going to leave that as dy over dx. Here, derivative with respect to x, this is the same thing as raised to the 1/2 power. So bring down the 1/2, x squared plus y squared. Subtract 1 from the exponent. 1/2 minus 1 is negative 1/2 times derivative of the inside. Derivative of x squared is 2x plus the derivative of y squared is 2y times dy over dx. Okay, so let's simplify this a little bit. This is y plus x dy over dx equals 1 over 2 x squared plus y squared to the 1/2, positive 1/2. And in the numerator, this is 2x plus 2y times dy over dx. Okay, so my goal here is just to get dy over dx by itself, nothing fancy. What I could do immediately, I can cancel the 2 over here, and then I'm going to multiply by x squared plus y squared to the 1/2 to both sides, or the square root of this. So this will be, if I distribute y, square root of x squared plus y squared plus x dy over dx, square root of x squared plus y squared equals x plus y dy over dx. Then I still want to get dy over dx by itself, so I'm going to subtract x from both sides, and then subtract this x dy over dx square root to both sides as well. That's square root x squared plus y squared. Sorry, this is a little sloppy. This cancels, this cancels. So my left side, I have y square root of x squared plus y squared minus x equals y dy over dx minus x dy over dx square root of x squared plus y squared. Now, since I have dy over dx on the right side, I could just pull it out from each term. So I have y minus x square root of x squared plus y squared equals y square root of x squared plus y squared minus x, which is not under the square root. This is all multiplied. Opposite of multiplying is dividing by this entire term, all divided by y minus x squared of x squared plus y squared. And then since dy over dx is by itself now, this will be my final answer.